Hey guys, thanks for coming. We're gonna wait just a couple minutes until more people arrive. And while we're waiting, I figure we can get some questions out there. Let's do this one. Which would best describe the status of your Office 365 deployment? Is it already implemented? Is it in the process? Are you evaluating, researching, or no deployment's been planned? All right. Okay. All right, guys, next question. Which would best describe your major objective for this webinar? You can select one. Solving an existing Office 365 problem, planning an Office 365 deployment, selecting an Office 365 SD-wan network architecture, using Cato for Office 365, or other. All right, we'll give it a couple more seconds. Perfect, thank you guys. And now I'd like to say hi and welcome everybody to today's webinar, 5 Ways to Architect Your WAN for Microsoft Office 365. Just a couple of housekeeping items before we get started. You're welcome to submit questions at any time using the chat window on the right-hand side of your screen. We'll go over all questions at the end of the webinar. And of course, there will be a recording of this webcast available to you within a couple days. It's my pleasure to introduce today's speakers, Dave Greenfield and Steve Garcon. Dave Greenfield is a veteran of IT industry. He spent more than 20 years as an award-winning journalist and independent technology consultant. Today, he serves as a secure networking evangelist for Cato Networks. And Steve Garcon brings more than a decade of experience helping global enterprises design, source, and implement wide area networks, WANs, with all major SD-WAN providers, MPLS services, and telcos. Let's get to these 2 quick poll questions before we move on. Is your company happy for the most part with Office 365? Yes or no? Okay, and the next question is, have you ever experienced network-related problems with Office 365? Yes or no? All right, thanks everybody. Steve, can you please get us started?
Thanks, Bonnie, and thank you for everyone attending. I'm sure all of you or most of you are Office 365 users, and some of you may be happy and some of you may be frustrated depending on the size of your enterprise and your global footprint. On the screen here are basically some frustrations that Gartner has surveyed, showing that 29% of people, of enterprises using Office 365 have a hybrid implementation, but they have some frustrations with the implementation. Service performance is often a problem, and there isn't adequate support for high-performing mobile access to Office 365. These are important issues, and we're going to address the architecture of Office 365 for your WAN and how we can address these problems. So what makes Office 365 challenging? Well, one of the big challenges is that network professionals are dealing with one instance of Office 365 globally. So to have the best performance, you want to have the most direct link possible. And while you may connect to a regional data center, depending on your geography, you may need to traverse the Microsoft Cloud to reach your customer data. And we're going to have a poll question now. Bonnie?
All right. Which Office 365 application presents problems for your network? You can select any that apply. Skype, audio or video, SharePoint, Exchange, OneDrive, Word, Excel, PowerPoint. We'll give it a couple more seconds here. All right, thanks everyone. Back to you, Steve.
Okay, thanks. The traditional MPLS WAN with centralized internet security is used by most enterprises that have an MPLS network, but it's not very efficient for Office 365, since in many cases, you're going to be accessing the internet by way of an MPLS network, and this is going to increase your latency, and by virtue of that, you're going to reduce your performance pretty dramatically. And when you look at the latency thresholds that Microsoft and Gartner published, the so-called Trombone Effect of this network design is going to hurt performance. You're basically going from the branch over the MPLS network to the gateway, to the internet, and it's a long path. Now, I've got a client that was implementing Office 365, and they found when they implemented it that their European locations were having a terrible performance issue. And this was exactly due to this, the Trombone effect. All of the locations in Europe were going over the MPLS network to North Carolina, and then from there, they were going out to the internet to get to Office 365. All the traffic was going over MPLS, and when they migrated to an SD-wan, they were now able to go directly to the internet. And we'll talk about that topology in a bit. So what are the alternatives? We have a number of network design alternatives that we're going to consider when implementing Office 365. Each has its pros and cons, both from a performance perspective and a cost perspective. So let's explore those. We're going to consider these 6 bullets, which are basically the keys to optimizing the network architecture for Office 365. First off, high throughput's very important. High throughput's going to affect the response of any of the Office 365 applications that have any significant file size. Okay, so you've got issues related to downloading files, getting emails that have attachments, accessing SharePoint. This is impacted greatly by latency. So just because you have a big pipe isn't going to provide you with high throughput. You're going to want consistent performance so that your users, your customers, so to speak, are going to have the same performance all during the workday and not have periods when things don't work properly. You have to consider centralized security. If you're going to have breakouts at each of the offices, how are you going to manage the security to protect your WAN from invasion? And obviously, easy deployment. Most companies don't have a lot of resources. You want to make it easy to install and configure. And another thing that many companies don't pay attention to is mobile support. There are more and more mobile workers out there, and how is the mobile worker going to access Office 365? Then this is all going to have to be balanced by the cost. You want to do it cost effectively. So the first approach is distributed internet access, and this is the easiest approach with distributed internet from every location that's using Office 365. Now, there's no guarantees of performance when you're connecting to the internet directly, and in some parts of the world, such as China and Africa, it might be completely unacceptable to take that approach. It's also important to consider the quality of your local internet service provider. Do they over-provision their network? Do they have good peering relationships to minimize hops? This lowest cost approach is the easiest to implement, but you have to be careful and do it right. Now, the internet presents a number of challenges with Office 365. And the reason it's so challenging is there's a combination of packet loss and latency in the last mile, followed by how efficiently your ISP peers with an internet transit backbone, which will then route the traffic to the ISP that will then connect to the Office 365 IP. Routing can change depending on internet traffic and resulting in variation in the user experience. So the selection of your ISPs and their peering relationships are very important. You don't want to just make a decision based on the cost of your internet connectivity. Now, the combination of loss and latency can have a big impact on throughput. And this graph is something important to appreciate because as packet loss increases, your throughput decreases. And the same applies to your latency, your round trip time. As your latency increases, your throughput again decreases. So for example, capacity guidelines within Microsoft IT were formerly 110 kilobits per second per salesperson and 300 kilobits per second per developer. And as services have become more data hungry, teams have become more widely dispersed, and the typical user, regardless of the job functions, is now estimated to use about 400K of bandwidth during normal business hours. Now, although this is a subjective guideline, it can be affected by many factors, such as the concentration of the number of users, the size of a campus, remote access, non-user access, and so on. But it's a practical starting point. You want to estimate the initial capacity that ultimately reduces the level of investment needed to provide the acceptable service and meet the business needs of the location. It's important to realize that your latency and your packet loss are going to affect your total throughput per user. Another design to consider is the WAN extension. Now, this approach provides consistent performance and maintains centralized security. You continue to use your MPLS network, but you provision the WAN edge device where a Microsoft Network Edge is located. And this eliminates the variability of the internet, but it's a costly approach. You'll need rack space in the carrier hub, a WAN edge router and firewall, and an internet connection and WAN port connection. For resilience, you're also going to want to have the same setup in a different data center. This is costly and not exactly convenient to implement. Next, we have ExpressRoute. Now, ExpressRoute connects your WAN directly to the Microsoft Network Edge and potentially your Office 365 installation. This approach provides consistent performance, centralized security, and high throughput. And it's also very easy to implement since your MPLS service provider is going to handle it for you. There's no internet involved, so you have end-to-end SLAs and you have quality of service. But you'll still need internet access for DNS resolution and the initial download of the client software. And this approach is very common for global enterprises that have many offices far from the Microsoft Edge. But you'll need to account for ExpressRoute and your carrier. Basically, ExpressRoute will be handled by your carrier, and they'll be setting up the connections for you in this particular setup. So we've talked about 3 different topologies for network connectivity in Office 365. So let's look at the 4th. Dave?
Thanks, Steve, and thank you all for joining us today. Like Steve has mentioned, there are a variety of architectures out there for addressing the challenges of delivering Office 365 over the WAN. The cloud-based SD-wan is interesting because it provides a very robust and easy way to implement topology for Office 365 connectivity. I know, Steve, I think when we've been speaking in the past, you've been a big advocate of this. And the basic approach is that whereas with WAN Extension, you were responsible for creating your own hub and all the costs and the challenges of deployment that were involved with that. With cloud-based SD-WAN, it's the service provider that handles that complexity for you. And more specifically, what that means is that you connect your mobile users and your data centers and branch offices directly to the SD-WAN cloud. The cloud provider maintains a backbone to which you're connecting to, and they also maintain a router in the same data center as Microsoft, as Office 365, and all your traffic gets dropped off at that point, traverses the local network within the data center into Office 365. So, whereas you may not have Express Route per se, you're getting very similar performance to it because it's just crossing the data center LAN. So you get great throughput, very strong performance because the backbone is being maintained by the cloud provider. Centralized security is integrated into the cloud. Deployment is much easier than certainly setting up your own regional hub. You inherit all the benefits that the SD-WAN provider brings to the other customers. So all of that great knowledge and insight you gain from. Mobile support is great because the mobile users now can access SD-WAN cloud directly. They don't need to be backhauled across the WAN, or they don't need to go across the internet per se, and be constrained, or I should say the internet backbone be affected by that performance. And price, it's not quite as great as if you were using distributed internet access, but the performance is much stronger than that, and the price is much more affordable than some of the other alternatives. The piece that we haven't really talked about that you see on your screen is our conversation has been speaking about Office 365, but as you start looking at other cloud services, IaaS services, pardon me, like AWS or Azure, or other SaaS services like Salesforce.com, you continue to inherit all the benefits that we're speaking about here. It just becomes another service on the network. So whereas if you were using ExpressRoute, that would have helped you perhaps with your 365 deployment. It wouldn't, of course, have helped you with your AWS deployment. You'd have to buy separate dedicated access for that. With cloud-based SD-WAN, you can improve both environments. Yeah,
and this approach really, from my perspective, is the ideal compromise between cost and performance. It's very cost effective, and the performance reaches a level of stability that is really hard to find, and it implements very easily.
Yeah, it's an interesting mix, isn't it, Steve? I mean, it kind of gives you the best of both worlds. So yeah, that's very cool. So Cato is an example. The Cato Cloud is an example of a cloud-based SD-WAN implementation. Of course, we think we're the best example of it, right? And why don't we just walk through that for a bit? The Cato Cloud is a global SLA backbone that provides integrated and advanced security. Our application-aware routing algorithms and integrated WAN optimization significantly improve throughput, and we'll walk through that in a second in greater detail. At the same time, we have built-in advanced security that includes firewalling, IPS, and secure web gateway. This becomes both the perimeter security for your branch offices and for your mobile users. It also becomes a way of securing your WAN traffic as well, your site-to-site traffic. And it's all of that we call the Cato Cloud. It's that complete package. Connecting to the Cato Cloud, we have our Cato socket. This is our SD-wan appliance. It sits at locations and connects them both to the existing MPLS lines if they're there, as well as to internet connections, ideally dual internet connections. We also connect cloud resources and mobile users as well with our mobile clients. So you really have one environment connecting your entire enterprise into a single SD-WAN guided by common security and networking policies. So let's just dig into that a little bit more so we can get a better understanding of how this works. As we mentioned, the combination of latency and packet loss undermine throughput. Our multi-segment optimization addresses each problem in different ways. In the last mile, we use dual internet connections that are run in active-active to maximize capacity and availability. As we mentioned, packet loss is a major problem. We use forward error correction in the last mile to recover lost packets. And it's precisely because the distance between the branch office and our POP, which the Cato socket is connecting, is so much closer than between the Cato socket and the final destination, which in this case would be the Office 365 destination. It's precisely because the distance is so much shorter that FEC and our other algorithms work so much more efficiently than they could have if you were having to force them to work across the full connection. Cato also independently optimizes the middle mile. First, we choose the best SLA back carrier for every packet, routing on a carrier and packet by packet basis. We proxy the TCP connections, so that allows us to give the appearance of being, give the appearance to the sending TCP client that's much closer to the TCP server than it thinks, which basically means that they can use very large TCP windows, and bottom line is improve the throughput. It really will depend on your particular environment, and we'll see a demo shortly illustrating the power of this kind of technology, but a lot of our customers report seeing a 10x to 30x improvement in the file transfer performance. We also are helped significantly by the ability to eliminate packet loss and recover from packet loss. We eliminate packet loss by carefully controlling the environment, and we eliminate any outstanding packet loss by employing our FEC algorithms. And finally, in the last mile, we use our cloud optimization techniques. And there's a range of techniques here. In the case of Office 365, we set egress points on our global network to exit the traffic at the Cato POP closest to the customer application instance. The Cato POP is co-located in the data center that's connected to the same internet exchange point as the leading IS providers, such as Amazon AWS or Azure in our case, in this case. And this means we can drop traffic right off at the cloud's data center, just like a premium connection, as we saw in the previous slide. So to summarize, it's a unique architecture. It combines both edge and backbone-specific optimizations. It allows us to maximize throughput end-to-end for both WAN and cloud destinations. It's a lot here. We'll speak a little bit more about it as we move through the demo. Certainly, if there are questions, we'll be happy to address them at the end. So in the demo, we're going to look at an example of optimized access to 365. What we have here is a headquarter in Chicago. The company was based in Chicago in this scenario, and they established their 365 instance there. As they grew, they expanded into Frankfurt, China, and Singapore, like a lot of companies do. And because the instance was originally created in Chicago, now they need to go back to Chicago to access that instance. Without Cato, they'd be connecting to the local Microsoft Edge in their given region. It would cross the Microsoft Cloud, as we saw, as Steve explained previously, and then it would be backhauled into Office 365, the instance in North America, and then with the results returned back to them, all the time traversing both the Microsoft Cloud and the internet. With Cato, as we'll see, those local connections in Frankfurt, China, and Singapore connect to the nearest Cato POP. They're right across the Cato backbone and get dropped off at Office 365. We'll look at file transfers first across the public internet, pulling down files from SharePoint, and then we will connect the locations to the Cato Cloud and evaluate the impact on throughput that the Cato Cloud has. Here you see remote desktops in our branches. Singapore is at the top left of your screen, China on the right, and the Frankfurt office on the bottom. The Cato management application is open on the lower left-hand corner, showing the full network deployment. We've started file transfers from each desktop over the internet. We're pulling down a 512 megabyte zip file from the SharePoint instance in the US. You can see from the Cato management screen that none of the branches are currently connected to the Cato Cloud. Without Cato, we get between 100 and 900 kilobytes per second. Again, that's going to vary based on internet conditions. Now what we do is we connect each of the offices to the Cato Cloud. First, you can see that we've connected Frankfurt, that's the Frankfurt user. Now we've connected the China user, and soon Singapore will be connected. Already we're seeing that in Germany, we've realized a 7x improvement in performance. In China, we see a 4x improvement. Over in Singapore, look at that. It's a 44x improvement in performance with the Cato Cloud. Now again, those numbers will vary based on internet conditions, but it underscores the power of Cato optimizations in our network. So let's go over a little bit about what we've discussed here today. And Steve, feel free to keep me honest here, jump in here if I'm missing anything, all right? We've covered three basic issues. We've talked about the Office 365's core challenge as it relates to networking. We've talked about a variety of architectures that address those challenges, and then we've honed in on the Cato Cloud. Office 365's networking problem has a lot to do with latency and packet loss that's incurred as you start moving across the internet, across long distances. If your implementation is within a given region, within North America, for example, you may not be seeing that challenge. It also depends on the kind of applications that you're running, right? In some applications, as we saw, are more tolerant than others. Right, Steve?
That's right. Yeah, especially basically, anything that uses large files is going to be painfully slow as your latency and packet loss grows.
That's right. So, if your instance is in North America, I don't know, your location is in New York, New Jersey, it's probably fine. You probably don't have a challenge there with access. You will have a challenge with distributed security and providing and mobile apps, making sure that mobile users are secured and they're seeing the kind of performance you'd like them to be getting. But in terms of throughput from your locations, if they're close enough to 365, that probably won't be a problem. It does become a problem though as your company expands, right? So as you open up branch offices in overseas, Europe, in the Asia-Pac, as we saw in our demo, particularly in China, we've got the Great Firewall of China, as it's known, where there's a lot of latency that's being introduced. Then it becomes a much bigger issue. And then we walked through a number of different architectures. Steve, you introduced those, so I'll let you recap that.
Okay. One of the approaches that is commonly used is, which suffers due to the trombone effect, is your classic MPLS network with a central security gateway. And so traffic is going to be going over the MPLS network to your security gateway, then out to the internet. And
then of course, then you're also using your MPLS backbone, so that's incurring all the costs of MPLS, right? To trunk traffic that basically will be going out to the internet anyway. Exactly,
and using Office 365, you're going to be using a lot more traffic than if you're basically using the legacy approach to your network, where there might be regional installations of your exchange online and things of that nature.
Right, right. So then you also have WAN Extension, where you're setting up a regional hub, right? And you're pulling your WAN out closer to the Microsoft Edge, but there you're having to deploy that regional hub, and that all the costs that are involved with that, and the challenges that are implicit in that kind of architecture.
Exactly. And then there's ExpressRoute, where again you're using your MPLS network, and you're paying for ExpressRoute to connect to the Microsoft Cloud, and right. That's going to give you good performance, but again, you're dealing with the high cost of running an MPLS network, and it doesn't really do anything for your mobile workforce at all.
Steve, I know you were, before you were touching on some of the theory and some of the things that you were trying to lay out. There's a lot to cover. Sometimes we race through these things faster than we'd like. I'm just curious. I want to bring you back a little bit. What have your customers done? Have they used ExpressRoute? Have they shown a preference for one architecture or the other?
Actually, I have clients that are eliminating ExpressRoute. They're trying to reduce the cost of their wide area network infrastructure, and they're discovering that there's approaches like we've discussed here that can give them the performance they need while dramatically reducing their cost. So we have companies that are eliminating MPLS or are dramatically reducing MPLS and then having direct breakouts over the cloud.
Okay, super. And then we also then moved on to the cloud-based SD-wan, which I think we both felt offered the best combination of any of the architectures. Cato Cloud, it is an example of a cloud-based SD-wan. It does bring not just network capabilities with a global SLA-based backbone and WAN optimization built into it. It also brings security optimizations or advanced security. So provides all the firewalling, the IPS, the protection that you would need to secure your branch offices and your mobile users. You wouldn't then have to deploy appliances out there or backhaul the traffic to a central security access point. You'd be able to give them direct native access to the internet and have the traffic secured by the Cato Cloud. It gives you MPLS-like performance at internet-like prices. And with that, I think we're out of time. I want to thank you all for joining us. I'm going to hand it over to you, Bonnie, and we can take any questions that folks might have.
Thank you. Before we get to the Q&A, which we have a lot of great questions, I just would like to run this quick poll. Would you be interested in a free estimate of your networking and security cost reduction using Cato? You can answer now. And while you guys are answering, we can get started on questions because we are running short on time. Steve, what suggestions do you have for rolling out 365 to remote users?
Well, I think you have to pay attention to using the modeling tools that are available on our website or elsewhere on the web to figure out what bandwidth do you need for every location. And you want to assure that the internet connectivity is with an ISP that has good engineering practice. Don't make the decision just on price, because you want to understand ISP utilization levels, packet loss statistics, and get evidence that the ISP routes traffic based on the best path. That's something a lot of people don't understand. Recognize that latency and packet loss affect your performance. You want to pay close attention to mobile access, because the workforce is increasingly mobile, and don't neglect that. And consider a cloud-based SD-WAN provider for your best performance, unless your company can really afford a global MPLS network with ExpressRoute.
Steve, I think you had collected a bunch of tools on your site, which folks might find interesting. A lot of them have to do with Office 365 and help you with that deployment, but they also have to do with networking in general. You also have a bandwidth calculator, I think, a throughput calculator that could help.
That's right.
Where would folks go for that?
They could go to our website at www.sd-wan-experts.com. It's sd-wan-experts.com. And if you click on the blog, You'll find a lot of those tools right there, as well as lots of interesting articles related to SD-WAN and wide area networks.
Super, thanks.
Okay, great. And Dave, what WAN optimization equipment does Cato use to improve file transfer performance to Office 365?
Oh, that's a great question. Thank you. So Cato actually has developed its own code stack from the ground up. So everything that you see in the Cato Cloud is built in-house. It's going to take me too long to walk through all the optimization techniques that we use here. You have that slide. Certainly contact me offline, and I can go through in great detail any questions you have. I have a lot of experience in WAN optimization. I'd be happy to answer any specific questions you might have.
Okay, great. And what other cloud platforms can be connected into Cato Cloud?
Oh, I guess that's for me. Really anything. We've got customers today. They're connecting to Azure and AWS. We've got a wide range of SaaS applications that are running across us, including Salesforce.com and obviously Office 365. So they all can benefit from the optimizations provided in Cato Cloud.
All right, last question we can fit in is, what security services does Cato offer today? This is for you, Dave.
Well, yeah. So as you saw before, we've got next generation firewalling. That's both for outbound traffic onto the internet and also site-to-site traffic on your WAN. We recently introduced the Cato IPS as part of our advanced threat protection. So you can get that today as well. Gosh, we have secure web gateway and URL filtering. I encourage you to visit our website, catonetworks.com, for the most current list.
All right, great. Again, thank you everybody for attending. Thank you, Steve, and thank you, Dave. We'll see you guys at our next webinar.